Greetings, everyone. Welcome to the 204th session of the online Optom Learning Series, OOLS. And for today's session, we have with us Professor Ariela Gordon-Shaag. Professor Ariela has completed her BA with a major in chemistry, and then she earned her MSc and PhD as well. Her interests in vision science developed during her postdoctoral training, where she studied phototransduction. In 2007, she established the master's program at Optometry at the Hadassah Academic College, and she was the director of the program until 2013. She was then the chairperson of the Department of Optometry at the Hadassah College for 2 terms, and then recently she heads the school. She's the Dean of the Faculty of Health Science and Society. Her research areas are more towards epidemiology and etiology of keratoconus, where she has done extensive research and published scientific papers and presented in national as well as international conferences. On the professional upfront, she is a fellow of the American Academy of Optometry and also sits on the scientific committee of the European Academy of Optometry and Optics and attends various national, international conferences, putting her thoughts and efforts, and also closely associated with the World Council of Optometry. And today, Prof. Ariela is going to talk to us, I think, the hotcake topic when it comes to research area, myopia, and she's going to share her views on the influence of light, near viewing, and education on the development of myopia. So welcome, Prof. Thank you so much, for giving us this time on the Sunday evening at your end. And let me leave the screen time to you, please.
Okay, so I'd like to thank Farquddin and the online optometry learning series for giving me this opportunity to talk to you. It's always so fun to meet and hear from students and faculty and practitioners from all over the world. I know that we've made quite a few polls for this presentation, and I'm also going to ask you some questions. And so it would be really great if I get feedback from you both in the chat and in the polls. So I'm going to talk about the influence of light, near viewing, and education on myopia development. And I was just talking with Farquddin about international conferences, and I said that the best part of international conferences, or any conferences, are the informal sessions where you can meet people and share ideas. In 2018, I went to the American Academy. I don't remember where it was, and I met Professor Lisa Ostrin from the University of Houston, and we started talking. And we had these great ideas, and we said, let's apply for a grant to fund these ideas. And we applied to a grant from the U.S. Israel Binational Science Foundation, together with my colleagues at Hadassah Academic College, Einat Schneer and Ravi Durham. So I'm going to tell you a little bit about that research that we've been doing. So the outline is we're going to talk a bit about the background of etiology of myopia. We're going to talk about Israel a bit. Then we're going to talk about natural experiments and the results of natural experiments and future studies. So I really like to start any research talk or anything with a case because, in the end, we're here to help people. And so I'm going to introduce you to one of the kids who comes to the clinic at Hadassah Academic College. We have permission from his parents to use this picture. And his name isn't Danny, but we'll call him Danny. Danny's 10 years old. Both of Danny's parents are myopic. He presented in March of 2022 with minus 250 with a bit of cylinder in his right eye and minus 225 and a bit of cylinder in his left eye. His vision is pretty good. He came back less than a year later with his chief complaint that he just wasn't seeing as well. And already his sight, his refraction is worse. He's got minus 3.5 with a bit of cyl in the right eye and minus 3 in the left eye. We see this kid is really progressing. And my first question for you is, how can we help? What can we do as optometrists or as practitioners to help Danny? And it would be great, I'm looking at the chat now, if you guys could write ideas in the chat. We'll wait a minute. I see some great answers here. SMAR, environmental modifications, ortho-K lenses, prescribed contact lenses, atropine, myopia control glasses. So great, we have some great ortho-K and atropine, myopia control glasses. Okay, great. So in order to help Danny, and not only just in order to help Danny, in order to help other kids in the same situation, it's important for us to understand what causes myopia. What causes myopia and why is the prevalence increasing? So I'm sure you're all familiar with this graph that came from a paper from the Brian Holden Foundation that has been tracking the prevalence of myopia since the year 2000 and predicting what the prevalence will be in the year 2050. And one thing that we're really certain of is that the prevalence of myopia in the world is increasing. From 22% in the year 2000 to 34% in the year 2020, with a prediction that by the year 2050, half the population in the world is going to be myopic. I can tell you that in Israel, there's some pretty good studies that are done in army recruits that shows a similar trend, that the prevalence of myopia is increasing. So the first poll that I'd like, if you could please have the poll, what causes myopia? You guys can answer one question, one answer. Oh, multiple choice. You can answer several things. What causes myopia?
Okay, great. So, Prof, I'm gonna share the results now, and it seems that majority of them are thinking about electronic device usage. People do say it's genetic, we get from parents, and yeah, I think almost all the options, but majority is electronic device, and 40% of them probably educational system as well. Yeah.
Okay, so let's talk about that. So here we have a kid with myopic kid, and the things that you mentioned were educational system, parental myopia. A lot of you thought electronic devices. I wonder what you're going to think at the end of my talk, and that daylight is protected. So we don't know what causes myopia, but we do know that there's an association between the prevalence of myopia in a country and the type of education system they have. On the y-axis, we see the prevalence of myopia in percentages. And on the x-axis, we see different places in the world, from Eskimos, people in Nepal. And here on the right, at least my right part of the slide, are modern East Asian educational systems, where we see more than 80% of the kids are myopic. In modern Western education, we see it ranges from, let's say, 20% to 40%. And when there's limited education or no formal education, we see the prevalence of myopia is even lower. So there's definitely something, and we don't, at least from this slide, at least from this graph, we don't know what that is. There's some sort of association between education and myopia. So one of the possible mechanisms of the association is reading and near work. So if you look at a literate society, societies where most people don't read and write, there's almost no myopia whatsoever. And the minute the kids in those societies start going to school, all of a sudden you see kids with myopia. Does that mean reading and near work cause myopia? Well, they're associated with each other. And myopia is associated with proxies for near work, like intelligence, time in school, and questionnaires. But the rate of literacy has not changed in the past 20 years. So it would be hard to understand how this would be causing the rise in the prevalence of myopia in the past few years, in the past 20 years. Okay, exposure to daylight. So there's a lot of good research in the past 20 years, past 15, 20 years, that being exposed to daylight protects children from developing myopia. And this cartoon kind of shows that. This is a scene from the 1990s. A father says to his kid, "What kind of child are you? You stay outside all day. Stay indoors for a time and study." And I have young children, so I could tell you this is what happens now in 2023. The dad says to his son, "What kind of child are you? You stay outside all day. Stay outdoors for a time." So there's a lot of good research that shows that being outside in the sunlight is protective for developing myopia and that it's dose dependent. Okay, parental myopia, you guys said you get it from your parents. This is the genetic risk of myopia. We see a low risk when neither parent is myopic. We see a 6 times higher risk when both parents are myopic, and a 3 times higher risk when one parent is myopic. But again, genetics haven't really changed in the past 20 years. The genetic basis of myopia would not explain why the prevalence is increasing over the past few decades. And here's your number one choice, electronic devices. And, you can see here, middle school children and sometimes even babies are already exposed to electronic devices. But the prevalence of myopia started to rise in the world before electronic devices were so widespread. So it's hard to believe that electronic devices would explain the increasing prevalence of myopia worldwide. So I have another question for you. If you're scientists and you see this graph here, and how would you test if education impacts myopia? Like, pretend you could do any experiment in the world and you could write the answers in the chat. And how would you test if education impacts myopia?
But looking at the explanation, looks like everything could be a reason. Like based on your first poll, we have evidence that everything really contributes to having myopia, right?
Comparing homeschooling children, that's a great idea. So the person to relate time spent on time, to relate to time spent in education. So really the perfect thing, if it were ethical to do, would be to take different groups of children in the same country, preferably from the same ethnicity, divide them into controlled groups. And in one group, send them to, give them a regular Western education where they don't have that much homework and they have a lot of time to play outside. And another one, give them a typical Asian education where they have long school days, lots of time doing homework. That would be the perfect experiment to do, but it's not an ethical experiment to do. We can't randomly divide children into different education systems. But the reason I mention that is because in Israel, we have a natural experiment going on in that we have 3 parallel education systems for Jewish boys. And I'm going to tell you a little bit about that now. So I don't know, do you guys have Netflix in Israel, in your countries, and watch a television show on Netflix called Shtisel? This television show, and if you haven't seen it, I recommend going and seeing it. It's a really great television show, at least in Israel and the United States. It's on Netflix. It's about a family in Israel who are ultra-Orthodox, and you can see that they have this typical type of dress, and it's about their lives. So now I'm going to tell you a little bit about Israeli Jewish society. So Israeli Jewish society, there are 3 major religious groups. There's the ultra-Orthodox, who this is kind of what their adults look like. There's the religious, and there's the secular. And so the ultra-Orthodox have distinct clothing. They wear distinct clothing, and you can see these little boys here. They have these big skull caps, and they have these little vests going on. They have a segregated society. They the men and women are segregated. Men primarily study Jewish texts. That's what they do most of the day. And they discourage modernism. They don't let, their people don't use the internet, they don't use smartphones, they don't use computers. Religious Israeli Jews, they have Western clothing. They may wear the skull caps, the yarmulkes here, but their clothing is pretty much regular clothing. They're not segregated. They work in all different kinds of jobs, and they embrace modernism. They use the internet, the smartphones, etc. The secular society, again, has Western clothing, not segregated. They work in all jobs and embrace modernism, use internet and smartphones. So we see that there are these three groups of Israeli Jews, and they have three separate school systems. There's two public school systems. There's a public school system for religious children and for secular children, two separate systems. And there is an ultra-Orthodox school system, which is not public. It's a private school system. The boys in the ultra-Orthodox school system start reading and writing when they're 3 years old. The girls start when they're 6, and that's pretty much across the board that, religious and secular children, boys and girls, they start school when they're 6. But the boys in the ultra-Orthodox system start school when they're 3. They mostly learn religious texts. They don't have core curriculum, like math and science. The religious and the secular kids have a core curriculum. The schools are segregated. The boys and girls don't go to school together. The boys and girls in the other two school systems may or may not go to school together. And the boys have long hours of study. They typically have a really long school day. The religious and secular school systems are pretty similar, but the religious school system have a few extra hours of religious instruction every week. And I'm just going to give you kind of a look at the kind of texts that they're looking at. I know that you can't read this, it's in Hebrew, but if you could get a feeling for the kinds of font size and how close together the fonts are. This is an ultra-Orthodox text, the Talmud. This is a religious text from the Old Testament, the Bible. And this is a secular and religious first grade textbook, which, nice big letters and colorful. So the next poll, I'd like you to predict, based on what I've told you about ultra-Orthodox, religious, and secular boys, which will have the highest prevalence of myopia.
All right. So I think I'm just going to share the results with you there. Almost 60% think is the ultra-Orthodox boys would have highest prevalence, and then secular boys, and then religious, and a couple of them also think they probably would have a similar prevalence as well.
Okay, so somebody actually did this experiment. In 2019, a paper was published where they looked at army recruits. We have mandatory conscription in Israel, and so all the boys don't have to go to the army, but they have to show up for a pre-army medical exam. And so they have data on their vision and on their refractive error. And the results of this study, which I'm about to show you, the results of this study were just mind-boggling, okay? In the ultra-Orthodox Jewish population, the boys, 82% of them had myopia, 82%, 8 out of every 10 boys. In the secular population, it was close to 30%, only 3 out of 10 boys. And the religious population, it was 50%, or half of the boys, the 17-year-old boys, were myopic. And the prevalence in the secular population is pretty close to the global average of about 30%. Now, all these children live in the same country, and it's not like it's not a big country. It's a little tiny country. It's maybe 400 kilometers long and 60 kilometers wide. So it's not a big geographical difference. All the boys in this study were from a Jewish ethnicity. So it's not likely to be a genetic factor. And so the authors of this study suggested that it has something to do with their educational system. And we said, wow, this is a really great natural experiment to discover the behavioral environmental factors that influence myopia. Because you can't a priori do that experiment of take kids and randomly assign them to different school systems, but we have kids whose parents are randomly assigning them to different school systems. And we want to study myopia in this unique population. So we just had a paper come out in Scientific Reports describing the baseline characteristics of this study. It's called the Israel Refraction, Environment and Devices, or IREAD study. And it's to longitudinally study behavioral characteristics and the relationship to refractive error in these three groups of young Israeli boys. And it's to determine the role of light exposure, near work, and electronic device use on the development and progression of refractive error. Okay, so remember that paper that I just showed you from 2019, the rate of myopia in the ultra-Orthodox was 82%, the religious was 50%, and the secular was 30%. I'm going to ask for the next poll to come out, and it has 5 questions. And I'd like for each question for you to hypothesize who will have the most time outdoors, near work at home, hours in school, use of e-devices. There are 5 questions in this poll, so maybe we'll give you a little bit more time to do all 5 questions.
Okay, so I am just gonna end the poll here. And there we go. I'm just sharing the results with you, Prof.
Okay. So yeah, I can see the results. So you guys think that the secular kids will spend the most time outdoors, that the ultra-Orthodox kids will be doing the most near work at home. They'll be spending the most time in school. The secular kids will spend the most time in front of electronic devices. And the ultra-Orthodox kids will have the most parents with myopia. So before I go on, I'm just going to say, wait a second. Most of you think that electronic devices are causing myopia. These kids don't have electronic devices. These kids are more likely to have electronic devices. So keep that in mind. Okay, so I agree with your hypotheses. And I kind of filled this table in red. And these were our hypotheses before we started the project. We figured that the secular kids would spend the most time outdoors, then the religious kids, and the ultra-Orthodox the least. The ultra-Orthodox would have the most near work at home and hours in school. We also hypothesized that the secular kids would have a lot more screen time than anyone else, and that there would be more parents with myopia in the ultra-Orthodox. So how did we do this experiment? Okay, so these are our research tools. We have one research tool that's called the ActiWatch. The ActiWatch is like, this isn't an ActiWatch, but it's a watch. It looks just like a wristwatch. The kids wear it, and you see this little dot here, that's a light sensor, and it senses light. You can set it to sense however often you want, but we had it set to sense light every 15 seconds. And the outdoor light is so much brighter than the indoor light that you could tell by the intensity if the kid is inside or outside. And typically more than 1,000 lux is considered outside. It also, I'm not going to talk about those results, but it also tests for sleep, physical activity. Subjectively, when the kids aren't in school, we gave their parents a questionnaire that had been used before that looks at near work, intermediate work, television, and electronic device use. So the subjects were healthy boys, ages 6 to 10, and we divided them into groups based on where they went to school, ultra-Orthodox, religious, and secular. And so this was the protocol. We called the kids in for cycloplegic refraction, in which we also measured axial length, and of course, we did a full eye exam. We gave the boys the watches to wear for 7 to 10 days. At the end of that period, the parents fill out a questionnaire and they return the watch. So what are our refractive categories definitions? So we use the spherical equivalent, the cycloplegic spherical equivalent average of both eyes. Myopia was less than or equal to minus half. And that's based on the International Myopia Institute guidelines. Hyperopia, remember these are young kids, we expect them to be a bit hyperopic. We considered equal to or greater than plus 250. And emmetropia was between minus 0.5 and 250. And of course, exclusion were kids with amblyopia, strabismus, hyperopia, any systematic disease, and high astigmatism of more than 3 diopters in either eye. Okay, so the outcome measures in the questionnaire. We asked the parents all sorts of questions about what their kids do. You know, how often are they reading books? How often are they writing? How often are they on handheld electronic devices? And near work, where we had categories that included reading, writing, and being on a smartphone or a tablet. Intermediate work, the categories were like playing cards, playing board games, working on a computer. And far work was greater than 100 centimeters, and it was basically watching TV or playing video games. Okay, so we recruited almost 200 kids, and 168 of them met our inclusion criteria. You can see in this table here, this is ultra-Orthodox, religious, and secular. The kids are about 8.5 with no statistically significant differences between the groups. But let's look at the prevalence of the rate of myopia. These ultra-Orthodox kids, these are 1st to 3rd graders, 46% of them, half of them are myopic. The religious kids, 1/3 of them are myopic. And the secular kids, like 25% of them are myopic. And there's a statistically significant difference between the prevalence of myopia in the ultra-Orthodox boys, 57 boys, to the secular boys, 44 boys, religious, 67 boys. Not only is there a higher prevalence of myopia, but the ultra-Orthodox kids have a significantly more negative average spherical equivalent than the secular kids. And there was no difference that was statistically significant in the axial length, but it approached significance. Okay, demographics. You guys, we're looking at your predictions here. You predicted that the ultra-Orthodox kids would have a higher prevalence of parental myopia. Almost all, the N here is smaller because some of these are siblings. Almost all the parents in the ultra-Orthodox kids had one or both parents with myopia. And with the secular kids, you know, 1/4 of them had neither parent with myopia. And this emerged statistically significant in that the ultra-Orthodox kids were more likely to have a parent with myopia than the religious or the secular kids. Children with cell phones, okay? 5% of the myopic kids, of the kids in the ultra-Orthodox kid group had a cell phone. 40% of the secular kids had a cell phone, and 21% of the religious kids had a cell phone, and it emerged statistically significant that the secular kids had significantly more cell phone use than the children from the ultra-Orthodox group. My next question, I looked this up for the talk. In India, what % of children ages 10 to 14 have cell phones? Can you please deploy the poll? That's fine. The right answer I got from the newspaper was 83% of children in India. I don't know about the other countries that you're from, but that's a really high number of people of cell phones. If you remember our study here, even in the highest group, only 40% of them had cell phones. Okay, educational background. The age they learned to read. So the ultra-Orthodox boys were about 4.5 when they learned to read, and the religious and secular kids were about 6 when they learned to read. And it's a statistically significant difference in that the ultra-Orthodox children learned to read at a much younger age than the other groups. How many hours are they at school? So on average, the ultra-Orthodox are 6.8 hours, the religious 6.3, and the secular are 6. And the ultra-Orthodox are significantly longer in school than the secular kids. And there's no difference between the 3 groups in terms of their grades in school. Okay. So before I show you the results of time outdoors, I have a question for you. It's a scientific question. Remember, we said in this cohort of kids, the ultra-Orthodox kids, half of them are myopic, and the secular kids, 23% of them are myopic. So which graph supports the hypothesis that time outdoors protects the children from myopia? A, B, or C? And can you launch the poll, please? The y-axis is the hours, average hours of outdoor time a day. Orange is ultra-Orthodox, blue is religious, and purple is secular. And which supports the notion that time outdoors is protective? And remember, we're basing it on these data here. Okay, so half of you thought that A is the right answer. Some of you thought that D was the right answer. I would say that A and D are closest to the right answer. In B, if light is protecting against myopia, then we would expect the ultra-Orthodox kids to have less light exposure than their friends. And this is the result of the experiment. The ultra-Orthodox boys spend less time outdoors, statistically significant less time outdoors than the religious or the secular boys. So indeed, these kids are more myopic and they are spending less time outdoors. And we found a similar results when we looked at the average white light exposure. Okay, another question. Remember what the first poll. Which graph supports the notion that screen use is driving the myopia epidemic? Okay, remember, 46% of the ultra-Orthodox boys are myopic, and only 23% of the secular boys are myopic. Which graph supports the notion that screen use is driving the myopia epidemic?
And this one looks like a tough question, Prof. There's no
it's a tough question.
Yeah. There we go. The
okay.
Results.
So I didn't ask you what you think the results are going to be. I asked you what would support the notion that it was screens. So if more kids are myopic, I would expect the ultra-Orthodox kids to have a lot more screen use, like in C. Okay. In C, we see the ultra-Orthodox kids. These aren't the results. This is a prediction. But now let's look at what the results really are. Okay. So ultra-Orthodox and religious boys spend much less time on screens. So the ultra-Orthodox kids had less than an hour of screen time, and the secular kids daily, and the secular kids had like more than 4 hours of screen time daily. And the religious boys had something in the middle. So if electronic screens, these results don't support the notion that electronic screens are driving the myopia epidemic, at least in this group of kids. And by the way, there was no difference between the 3 groups of kids in terms of near work at home. So those are our preliminary results. It's a longitudinal study. The kids are being invited back for a 1-year visit as we speak. And we're assessing their myopic progression and axial length progression. They get another ActiWatch and they get a questionnaire. And so maybe the OOLS will invite me back next year and I can tell you about the 1 year, about the longitudinal results. But I'm just curious, which group of kids will have the highest rate of progression after a year based on everything I've told you? Do you think that this is the poll 7? The ultra-Orthodox kids, the religious kids, or the secular kids?
I think almost 80% say ultra-Orthodox, yeah.
Yeah, that's what we think too. And as I said, when we finish collecting data by the end of this school year, we'll also know what the answer is, and maybe I can share it with you next year. Okay, so one of the things we wanted to do was to objectively measure viewing distance. with our hypothesis being that the ultra-Orthodox kids spent more time at shorter distances. And to do that, we have this device that's called a cloud clip. A cloud clip sits on the kids' glasses, or you give them a pair of, Plano glasses if they don't have them. And it sends out a beam of infrared light. The infrared light hits the object and is refracted back. And the object measures the amount of time it takes the beam of light to go out and back, and that gives you distance. The problem is that these kids would not wear this device. They just wouldn't wear it. They refused to wear it. We couldn't get any of the kids to wear it. So we said, okay, the kids aren't going to wear it. Let's try it on adults. So this is a paper that came out in Ophthalmic and Physiological Optics in January. And we're objectively examining near viewing behaviors in non-ultra-Orthodox and ultra-Orthodox young adults. As I said, we couldn't get the children to wear them. We said we're going to invite adults in and try it in the lab. So our hypothesis is, remember I showed you this text at the beginning. This is the kind of text that the ultra-Orthodox children look at. And it has all these really small fonts that are, the letters are crowded close together. And our hypothesis was because they read, their texts have such small fonts, they would be reading at a shorter reading distance. It's not only that they do more near work, the reading distance is shorter. And this is the demographics of the young men that we collected. There were 30 ultra-Orthodox young men, 38 non-ultra-Orthodox young men. And the non-ultra-Orthodox were significantly older than the Orthodox. They were all students and who were wearing it either during their religious studies or their school studies. In terms of percent of myopia, 87% of these guys are myopic and 68% of these non-ultra-Orthodox are myopic. That's not statistically significant. But the ultra-Orthodox men were had significantly more negative refractive errors than the non-ultra-Orthodox. So we brought them into lab and we gave them 4 tasks. One was reading a book. One was drawing. By the way, they weren't lying on the floor. They were at a desk. We gave them an iPad to watch a movie, and we gave them an iPad to play a game. And what we found is that when you look at the distance, and this is viewing distance in centimeters, if you look at the viewing distance of all the tasks combined, the ultra-Orthodox men are indeed doing things at a shorter distance than the non-ultra-Orthodox men. And this is primarily driven by reading. So they read at a much closer distance than their non-ultra-Orthodox peers. And there was no difference between the groups in the number of viewing breaks. So what are our conclusions? So first of all, subjectively and objectively, the ultra-Orthodox, religious, and secular kids have different behavior. The ultra-Orthodox boys are more myopic, start to read earlier, learn more hours during the day in school, use less screens, and spend less time outdoors. And the ultra-Orthodox young men read at a shorter distance, and they also watch videos at a shorter distance. So it seems like, at least in Israel, early reading, shorter reading distances, longer school days, and less time outdoors may explain the higher prevalence of myopia in the ultra-Orthodox Jewish community. But electronic devices are not driving the myopia epidemic in this community. And I'm just going to show you a few interventions that they've been doing in China. And one is they have these bars in the school that prevent the children from getting too close to the material, based on the notion that shorter reading distances cause myopia. And this is another type of intervention in China. And you can see it's a classroom, but the ceiling and the walls are made out of glass. And that's to expose these kids to a lot of outdoor light. So now I'm going to go back. This is last poll. Remember Danny from the first slide? How can we help Danny?
All right. So there we go. Here are the results, Prof. And yeah.
Okay, so 41% myopia control, that's a good answer. Spending more time outdoors, our results support that spending more time outdoors is going to be helpful. Read less and spend more time on smartphone. Our results support that notion, but I don't think we want to advise any parent to tell their child to use a smartphone more. Skip school and go to the beach, that was meant to be funny, and taking breaks while reading. Our results didn't support that notion, but it seems like a good advice. So, what are our future experiments? So we really would like to do objective measures of near work with children. I've talked to you about boys, but the girls would be very interesting to study as well, because based on what you know about the school systems in Israel, the ultra-Orthodox girls, their school system is very similar to the religious and secular kids. So we would expect them to have similar rates of myopia and similar light exposure. And I want to say thank you. If you want to contact me with any questions, you can contact me at this email address. You can use this QR code reader to get to my website, and there are links to all our papers. I'd like to thank my colleagues at Hadassah Academic College, Einat Schneer, Ravi Daron, Jonathan Levine, and Ariela Gordon-Shaag, and our colleagues at University of Houston, Dr. Lisa Ostrin, Dr. Julia Benet, and Kobe Bandari. And I think we even have a few minutes for questions now.
Yeah, thank you so much, Prof, for that thought-provoking presentation, because I understand that you took the example and the research experience from your region, but I think this could be applied through any region where you belong to, because we do have different schooling systems and different people lifestyle as well. You have private, as somebody I think in the chat mentioned about homeschooling versus traditional schooling. I think this is something to do with that as well. So thank you so much for sharing that.
I think that's a really good point. I think that this kind of research, this could be a paradigm for other countries that have unique populations, because we can learn a lot from these unique populations. And if anybody has an idea for collaboration, I'd be happy to hear it. So somebody asked me about a 3-year-old child with atropine. I don't know that we have good data about children that young.
Yeah. I
don't know that we have any data. I don't know what to tell you. On one hand, it's really hard to get children that age to comply with contact lenses or spectacles. But wow, I don't know that I would give a 3-year-old atropine. Does Lux work really? Does light really work to reduce myopia, and how does it function? That is a fantastic question. So, as I said in the beginning, there's lots and lots and lots of good evidence out there that exposure to outdoor light is protective for myopia development. There's not a lot of good research showing why. What's the mechanism? And that's like $1 million question.
That's right. And now I think with the newer research coming out of the low light level, red light therapy, and things like that,
it could be. It could be like one of the. It could be red light. It could be 100%.
Yeah. So I think more research is needed in the topic, and I remember somebody telling during one of the sessions that we don't really completely understand myopia. I think we probably understand less than 1% at this point in time. We have a lot to do in terms of research for myopia, right?
So, right. And there was a session at ARVO, at the Association for Research in Research in Vision and Ophthalmology. There was a conference a few weeks ago, and there was a session on the mechanism of myopia control. And the bottom line is we just don't know.
We just don't know.
There's a lot of hypotheses, but we really just don't know how it works.
Yeah, right. And I think the hypothesis as well, people do ask clinical questions, which is the best method to help patients with myopia progression. And as we said, we just don't know. We have to try what is available, what is convenient for the patient and for the clinician. And we just hope for the best in terms of follow-up, right?
And you know what, the advice of suggesting to parents that their children spend more time outdoors playing, that's just really good advice, even if it doesn't help.
Yeah.
That's just good advice. Children children are meant to play outside, in my opinion. So
yeah, at least if nothing, you can always start with spending time outdoors, But any tips, Prof, from your research experience and clinical experience? How do you really convey this to parents? Do you have a specific way to talk to parents and asking them to bring their kids outside? Is there any thoughts you'd like to share with us? How do you communicate?
So, I think it depends on the parent, and, they're talking about artificial intelligence and medicine, and how artificial intelligence could do a lot of the clinician's job, but connecting with patients and parents is something that really only the clinician could do. And I think it's really about developing a long-term rapport with parents so that they'll listen to you when you give them advice about interventions for their children.
That's right. Yeah. And I think having a strong base of your clinical decision making and feeling confident in front of the parents also helps, right?
Yeah. And, having a good evidence base, and that, one of the things I would advise is like to check the International Myopia Institute publishes white papers every few years regarding, the state of the art of myopia and myopia control. And I think it's really super important now more than ever to keep updated with the new information that's coming out. So like you said, that you'll be confident and, coming from a strong evidence base. That's
right. And I think one question was popped up while you were talking about, the device which ideally measures the reading distance or the near task distance, which was difficult in kids. Is there any specific reason? Probably somebody would want to know, why did the kids not like it, or was it?
So Lisa Ostrom is able to use it in children in Houston.
Okay.
I just think the Israeli kids think that their friends will laugh at them. They don't want to look like they're different than anybody else. Yeah, I can't, I don't know. Classroom writing, students at the blackboard window, sunlight to different desks. So somebody asked about if we can engineer the classroom so children will get better light. So I know there's some interventions in which they have something called active recess. And during recess, they send the children outside. They could do whatever they want outside, but they can't stay in the classroom and they have to be outside. And that has been shown to slow myopia progression in the schools that embrace that intervention. So, maybe changing classroom lighting will help, but I really think we just need to engineer our school system that our kids spend a nice chunk of time outdoors. That's right. I think 15 years back in my school time, we had that 1 hour per day as the physical training period where we were sent outdoors. I'm not sure of all the schools had that facility of having a ground, but we were sent outdoor and, you were outdoors doing some physical exercises and things like that. I think now people are more into this computer training and having more of additional labs instead of that. So I think I know I have two sets of children, 3 in their 20s and 2 in their teens. And the children in their 20s, when they were in school, they would go outside and play ball during their breaks. They didn't have smartphones when they were young. There wasn't a computer lab in the school. They went outside and played. And now the younger kids, they could go outside and play, but a lot of times they stay inside during recess and they, play computer games. Right. I think that is something which needs to be conveyed to the educational system, and potentially that would be something which can be changed in the favor of myopia management.
Awesome. Great. So I think,
Okay.
yeah, we have taken most of the questions. Thank you so much, Prof, for sharing that presentation and also taking us through the results and also, kind of thought provoking us to look at the data in our, regional areas and look at how myopia prevalence is and how can we help patients. So thank you so much for spending your evening with us today.
Okay, my pleasure. Take care.
Yeah.
Bye-bye.
Bye. So we do have session planned at the end of the month. We will be sharing the details of the session. Until then, take care, be safe, and I hope to see you during the next session. Bye-bye.